33 sealed tubes are sitting on the surface of Mars right now. One of them may contain a 3.5 billion-year-old molecule that resembles a precursor to DNA. No one is going to pick them up. What did NASA find, and why did we walk away from it? In 2020, Curiosity drilled into an ancient rock in Gale Crater. What came back was the rover's biggest organic chemistry find, and they almost missed it. The sample came from the Glen Torridon region, clay-rich terrain that formed in the presence of water. Clay traps and preserves organic material. Whatever was in that lakebed 3.5 billion years ago, the clay kept it. Curiosity carries 2 cups of one rare chemical. Each can be used once. The team passed hundreds of rocks waiting for the right one. They used it on this one. This was it. Here's what came out. 21 carbon-containing molecules, 7 detected for the first time on Mars. The building blocks that started life on Earth, sitting in Martian rock for 3.5 billion years. But finding them on Mars doesn't confirm life existed. Meteorites carry organic molecules. No life required. Think of it this way. You can't find a cake baked 3 billion years ago. The cake is long gone. But if you find flour, eggs, and a measuring spoon, you found something worth paying attention to. Among the 21, a compound called an N-heterocycle, the same family of molecule that, on Earth, became part of DNA, never before spotted on Mars. That's the molecule that stopped everyone. Here's what makes it harder to dismiss. Scientists ran the same experiment on a 4.6 billion-year-old meteorite found in Australia. Same molecules. Proof the chemistry survives. Proof the method works. Someone confirmed the measuring spoon exists. Theory 1. Geology. Mars had water, clay, and heat. Give those a billion years, you get complex carbon chemistry. No life required. Boring answer? Probably correct. Theory 2. Meteorites. For 4 billion years, space rocks have rained on Mars carrying organic molecules formed in the cold between stars. The chemistry didn't form on Mars, it hitchhiked. Also possible, the chemistry doesn't care where it came from. Theory 3. Something on Mars made these molecules. Something that grew. Something that ate. Something that died in a lakebed that hadn't yet dried up and left its chemistry preserved in clay for 3.5 billion years, waiting for a robot to drill it out. Pause there. All 3 remain on the table. The experiment cannot tell us which one. This is not a cover-up. This is what honest science looks like. The data is real. The data doesn't yet let us choose. And the word yet is doing all the work. To choose, scientists need to bring the samples to Earth. NASA's Perseverance rover has been doing exactly that, sealing samples in tubes, caching them on the Martian surface. The plan was called Mars Sample Return, the top priority of planetary science. Remember those 33 tubes? In January 2026, Congress canceled the mission. So here is the situation. 21 organic molecules, a 3.5 billion-year-old rock, an N-heterocycle, the family of molecule that built DNA on Earth, the technology to bring it home, and the mission to do it, gone. Diagnostic of life, lead scientist Amy Williams. Those are careful words, chosen deliberately. Williams won't name what life it could diagnose. Neither will I. The samples are ready. The science is ready. The will is not. The tube knows. The tube isn't talking. The ingredients are there. The mission is canceled. The answer is sitting in 33 sealed tubes on Mars right now, waiting for a ride that isn't coming.